if you want to try it. Okay, let's take the now some interference. Let's discuss few problems on interference. There are 2 point sources are there. They're separated by a distance, say like a d. Let r be the radius of the circle. So let me take this particular point where OP is equal to r. Let lambda be these two are coherent sources. S1, S2 are coherent. And let lambda be the wavelength of waves. Okay, if I move in a circle, what will happen to number of maximas, minimas, which I'm going to measure here? How many maximas, minimas I'm going to measure here? If I go around in a circle, and the detector, what will move in a circle, find the position, find the number of maximas, minimas, and their position. So what is that point P? Point P is a detector, that one. Also, we'll make a question. Find the number of maximas and their position on a circle of radius r. So I kept a two coherent sources separated by distance 2d symmetrically above the origin, and I'm going to move in a circular path around them in a circle of radius capital R. Then how many maximas and what about their positions I'm going to notice here. So first, what will happen? The wave generated by this source will reach point P, and the wave generated by this source will reach point P. The two waves, is there any path difference between the waves? Yes, there's a path difference. Are you noticing? There's a path difference, no? So both the things will generate a wave. This will send a wave. No, is there any path difference of the waves when they arrive at point P? Yes, definitely. So what is that path difference? So the path difference is what we notice is equal to this one. Let me take this is theta. And now what is the condition? I'll put R very much greater than D. If R is very much greater than D, any conditions will arise here. How the diagram will appear like this. I'm trying to explain geometrically so that it will be easy for you. These are the two sources, S1 and S2, and there's a point P, no? Look at this one now. So what is the angle made by, so if I say that this R is very much greater than D, the separation between the sources, then what is the angle made by these two with the horizontal line, with the reference horizontal line? Should be equal. And that is what the angle made by the midpoint also. All three should subtend same angle, no? Because the reason for that, what is the reason for that? Because R is very much greater than D that one. So you will get a situation of like this. The angle made by the line joining S1P, OP and S2P with horizontal, the angle subtended by the line joining S1P, S2P and OP with horizontal will be same. That is what the theta. So this theta, which is here, no, I can also write it here. I think this is going to, this condition is very important. Because here so this theta, this will be different. If R very much greater than D, means like you take this is 10 meter, this you put 1 centimeter. Definitely open with protractor, you measure this thetas, no, they're going to be same. Okay, some are asking question. The diagrams are not clear. I'll put it again. Huh? You can see this. So we'll agree this, the condition. So this is 2D and this is almost equal to R, no? So when R very much greater than D, then all these lines S1P, S2P and OP will subtend same angle with the horizontal. This is the one basic necessary condition. Then because of that, I can take this also theta, this also theta. So we have a triangle. Look at the triangle. Delta X. This is 2D, no? Shall I say this is a path difference between the waves? Compared to wave 2, this much of additional path the wave 1 will cover. This much of additional path the wave 1 will cover. So therefore now the delta X, so cos theta should be equal to delta X by 2D. Now I'm interested to search maxima. So for maxima, what shall I do? N lambda. So now relation between lambda and this particular thing is needed. So let lambda equal to D, let me put it. Let the wavelength of waves be lambda. Let lambda equal to D. We'll put a condition. If lambda equal to D, then what do we get? Cos theta equal to N by 2. What are the possible values of N? N equal to 0, theta will be 90 degrees. N equal to 1, N equal to. So what are the possible values of N we can pick up? N equal to 0, N equal to 1, N equal to. If you put N equal to 0, what do we get? Cos theta. Theta should be equal to 0 degrees. Oh, sorry, N equal to 0, theta should be 90 degrees. N equal to 1 by 2. So this will be 60 degrees theta. N equal to 2, theta will be 0. So where all we see the maximas, the angular positions is 0, 60, 90. So now if I draw a circle, position of maximas. Will I get any maxima? Yes, theta equals 0. Yes, it is. Next maxima, theta equal to 0 degrees. Next maxima, theta equal to 60 degrees. Next maxima, it'll be here. Similarly, due to symmetry. So tell me, like, if I go around in circle, how many maximas I'm going to measure? If I go around in a circle, how many maximas I'm going to measure? Let me define all that condition. R very much greater than 2D D and lambda equal to D, in fact. The distance between sources. Okay, how many maximas? Let's count 8 maximas. It all depends upon this lambda, the relationship between them. Lambda equal to 2D, you make it. Lambda equal to 3D, you make it. or lambda equal to d by 4. Oh, sorry. So how many maximas now for lambda equal to d? 8 maximas are detected by detected. Let me take one more question. So I do have 3 coherent sources, S3, S2, S1.